Hello my dears, very good morning to all. So in the last class we discussed about the power factor control in an alternator, right? In an alternator we discussed the power factor control and how can we improve the power factor. Power factor control in the sense the power factor is poor, whether it may be too much lagging or whether it may be too much leading. So we need a good power factor, means the power factor should be near to unity, then only that is a very good system. So in order to make that power factor towards unity, we did some adjustment in the excitation. So excitation play a vital role in the control of power factor in an alternator. Okay, so that is the peculiarity, that is called, it's a very important machine. Okay, alternators are the very important machine. So now we are going to deal with power factor control in motor. Power factor control in motor. So this is nothing but, my dears, motor. So there we are giving a P input and Q input, and here we are giving the excitation also, correct? Here we are giving the excitation also, and there will be a P0 output of motor. So let be PIM. Let be PIM means input of motor. Let be QAM means reactive power input of alternator. I mean synchronous motor. Okay, it's a motor. And P0M is nothing but the power output of the active power output of a motor. So like that, if copper losses in the armature are negligible, we can say that P input minus copper losses equal to actually P output of motor. Am I correct? PIM, P input of motor minus copper loss equal to P0M. If this is neglect means, if it is very negligible means, we can say that P input of motor will be equal to P output of motor. P input of motor will be equal to P output of motor. And likewise in the previous case, we have the basic equation for, my dear, P input as well as Q input. That is active and reactive power equation is there. First of all, the active power equation is, what was that? EF into Vt divided by Xs into sine delta. There is no change in that. It is sine delta. And again, it is nothing but Vt by Xs into, my dears, Vt minus EF cos delta. Just opposite. It was EF cos delta minus Vt in case of motor, in case of generator, but in the case of, it will be Vt by Xs into Vt minus EF cos delta. Is it clear, my dears? Is it clear? So now we are going to deal with how can we control the power factor in different situations. In different situations. Situation in the sense, likewise in the alternator, we took Vt greater than EF cos delta, Vt less than EF cos delta, Vt equal to EF cos delta. So likewise we have to discuss situations here. So let's discuss case 1. Let's discuss case 1. Okay. Case 1. Case 1 means, what is that? Let Vt greater than EF cos delta. Let Vt greater than EF cos delta. Which means, again we have the basic equation, my dear. You have to rewrite that equation. PIM and QAM we have to rewrite. It is nothing but Vt by Xs into EF sine delta, and this is nothing but Vt by Xs into Vt minus EF cos delta. Is it clear? So if Vt greater than EF cos delta means, Vt greater than EF cos delta means, what is the meaning, my dear? QAM is positive, correct? QAM will be positive. If QAM will be positive means, QAM into positive means, now the motor, what happens? The motor absorbs reactive power from the supply. from the supply. Because I already told you that the power factor of operation of the motor depend upon the supply only. And the case of a generator, the power factor of the motor operation, a generator operation is depend upon what? The load side. So there the load determines the power factor, here the supply determines the power factor. So now the motor absorbs reactive power, and Q is equal to positive means there will be a conventional flow of what? Reactive power happens. Here in case of a motor, the conventional flow of reactive power flow is from source to the motor. Am I correct? Supply to the motor is the conventional direction. So now the motor absorbs the reactive power from the supply because motor doesn't have sufficient reactive power in it. Why the motor has to absorb more reactive power if Vt greater than Ef cos delta under that situation? Because already it doesn't have that much reactive power in order to smooth flow of what? Active power across the machine. So what happened? The alternator will, the motor will absorb reactive power from the supply. So now the machine is in under excited condition, my dear. Because the excitation controls the reactive power now. If the machine doesn't having enough reactive power, then only it has to absorb from the supply. So the machine itself is under excited condition. That is the reason why the machine doesn't having sufficient reactive power in it. So now the machine is in under excited condition. So now the power factor is what? Lead or lag, my dear. The power factor will be lag because it is absorbing reactive power from the supply. So the power factor will be lag. So now this condition is we want to modify. So power factor is lag means this is not the desirable condition. This is not the desirable condition. Power factor should be always near to unity. So power factor lead is an undesirable condition. Power factor lag is also undesirable condition. So we want to improve this power factor. So what we can do for improving such power factor? What we have to do for improving such a power factor? See, so now the power factor is lagging. So for that, what we are going to, here the problem lies, that is the lagging. The reason for this lagging reactive power is that Vt greater than Ef cos delta. So that Vt greater than that Vf cos delta, that condition we have to break. That condition we have to break means we have to, for correction, for improvement of power factor, Ef increase. Field excitation you have to increase. What happened? Because Vt greater than Ef cos delta is the condition. We have to make Vt and Ef cos delta equal almost. Then it is a super system. So what we are going to do, we have to make this factor Ef cos delta, which is approximately equal to this Vt. For that we have to increase Ef. So we increase the excitation. If we increase the excitation, my dear, this, but likewise in generator, Vt into Ef into sine delta equal to a constant. Ef into sine delta will be a constant. So if Ef increases, sine delta decreases. If sine delta decreases, cos delta increases. If cos delta increases, combinedly Ef cos delta increases, because Ef is already increased and now cos delta also increased, so Ef cos delta increases. If Ef cos delta increases, what happened, my dear? this Q start decreasing. The Q started decreasing. If Q started decreasing, what happened to phi? Phi is equal to tan inverse Q by P. If this is decreasing means phi also decreases. Phi also decreases. If phi decreases means cos phi increases. That's all. If cos phi increases means IA or IL, load current, now the armature current. Simply armature current and load current both are same. Armature current decreases because phi A, cos phi, that is the power factor, and the armature current are in what? Opposite. It means it is inversely proportional quantities. So what happened? Finally you improved the power factor. Initially it was lagging. Now the power factor is increased. Power factor increased means it is closing or it is approaching to unity power factor condition. Now we improved the power factor. So in the examination, the question may be like this: present condition they will given. Present condition is Vt greater than Ef cos theta. Now this is the operation of the machine now. Then if excitation is increased, what happens? If excitation further decreased, what happened? This type of question you may expect. So if you have a total idea in your mind, my dears, this you can easily mug up and you can remember. There is no meaning in that. You have certain quotations like if that means this, that means this. You can mug up like this, but what is the meaning? At the center of the hall, examination hall, if you clearly know the concept, any question if you ask relating to this, you can simply play with that equation. P input and Q in QAM, PAM and QAM. If you know these two equations, my dear, and if you just know the concept, you can answer to any question related to this excitation and power factor control. Is it clear, my dears? Is it clear? So now we improved the power factor. Is it clear? So that is the case 1. Next you have to see case 2. In case 2, what had happened? Vt equal to F cos del. Suppose the motor is operating under this condition. Under this condition means, what is the meaning of Vt equal to Ef cos theta minus cos delta minus? Suppose these two are equal means, now the Q will be 0 because Q is nothing but Vt minus Ef cos delta. There is a term like Vt minus Ef cos delta is there in Q, right? So if these two are equal mean Q input will be equal to 0. That means the motor neither absorb nor supply any reactive power to the supply. Okay? Or the motor works in unity power factor condition. Okay? So the excitation is normally excited. Is it clear? So if Q is equal to 0 means what happened, my dear? Phi will be equal to 0 because phi is equal to tan inverse Q by P. If Q is equal to 0 means phi will be equal to 0. If phi will be equal to 0 means cos phi equal to 1. Cos phi equal to 1 means it is in unity power factor condition. So now the machine is superb condition actually. Now the machine is in super condition. But if you are eager to know, if you are a student, you are eager to know what happened in this situation. Suppose I am increasing my excitation or decreasing my excitation. Both cases we can see. So sub case 1. Sub case 1, if EF increased. So if EF increased, now what happened? This term start increasing. If this term start increasing means we have, my dear, already we have the Q equation. If this increases means Q will be negative. If Q will be negative mean what is the meaning? The meaning is that there will be, or there is a reactive power flow from motor to source. That is, the motor will goes to leading power factor condition, or the machine is said to be overexcited. The machine is said to be, my dears, overexcited. So what is the meaning of this? If Q, suppose the second term EF cos delta, EF increases, what happen? If EF increases, my dear, or I will say now, if EF increases means, how can we say like EF increases means sin delta decreases. Sin delta decreases means cos delta increases. So combinedly EF cos delta increases. If EF cos delta increases means that will become what? Negative. So you can say that Q will starts increasing, because Q was 0 initially. Now Q will starts increasing in negative direction. So phi will be increases. Phi will be what? Increases. If phi increases, cos phi decreases. If phi increases, cos phi decreases means power factor will be lower. Power factor will be lower than UPF. Means, so the motor now in leading PF condition, because Q will be negative. Q will be negative means what is the meaning? There will be an opposite direction, the power flow will happen. The opposite direction means normally the motor has to absorb power from the supply. Now the motor will deliver reactive power to source. So the motor acts like a so the motor acts like a capacitor, because only in capacitor there will be a what? A reactive power flow from what? The motor to source. That is the capacitor only which will supply the reactive power bus, my dears. Inductor will absorb the reactive power and the capacitor will supply the reactive power. That's all. Is it clear, my dears? If everything is clear, so now what happen? If we increase the excitation, the power factor will be leading. Under unity power factor condition, suppose increasing the power factor means the power factor will be leading. Okay, the power factor will be leading, my dears. I will explain that. Okay, so that is the sub case 1. Next, sub case 2. Sub case 2. If EF reduces, initially we increased EF, now if EF reduced, what happened? If EF reduced means VT will be greater than EF cos delta. Now VT will be greater than EF cos del and Q will be positive. Q will be positive direction because VT greater than EF cos delta will happen again. So initial condition now, it is like initial condition, right? So what happened, my dear? So what happened? EF cos delta, that's Q will be positive. If Q is positive, phi will be equal to what, my dear? Phi will be equal to what? Okay, let's. If EF decreases means sin delta will increase in order to make what? P constant, correct? EF decreases, sin delta will increases, so automatically cos delta also decreases. So combinedly EF cos delta decreases. EF cos delta decreases. Actually this should be first, right? You should write this first and you should write this first. Okay, right here. Okay, this you should write first and this again you should write. Okay, then only it will be like a what story? Write a story. Okay, so combinedly EF cos delta will what, my dears? It will decreases. So VT will be now what? Q will be positive, which means Q will be positive means what, my dear? Now the motor will absorb power, clearly reactive power from the supply. That is the motor, simply motor, no need to, that is lagging power factor condition. Lagging power factor condition. Is it clear? Similar to the first case, my dears. So we have to improve this lagging power factor, my dears. So what we have to do for increasing this lagging power factor? I mean, for improving this lagging power factor, what we have to do? What we have to do for improving this condition? What we have to do? The opposite thing you have to do. So there is no need to explain that because the opposite we have to do that. Okay. So the power factor will be lagging bus within a bus. Sub case 2. The power factor will be lagging. Is it clear? So if you decrease in the excitation, the power factor will be more and more lagging from the initial condition of unity power factor. From the initial condition of unity power factor, if you increase excitation, the inductor, I mean the motor will goes to the leading power factor condition or over excited condition. So now the machine is said to be under excited condition. Because the reactive power flow is from supply, right? The motor will absorb reactive power from supply. Why that motor has to absorb reactive power? Because it is there lack of reactive power in it. So it has to borrow from the supply, then only that working will be smoother. So what happened? The motor will say, array supply, my reactive power is very less, so please help me by giving some more reactive power, then only I can rotate. And convert my whole active power to the outward without any trouble of myself. So that is the words of a motor. And the supply will say, okay, I will give you the reactive power. And you have to change your board like you are under excited condition. That means this is your inability now. So you are under excited condition. So the motor will be now in under excited condition. Is it clear, my dears? So that is the sub case 2. And next, case 3. Case 3 means what is, my dear? Vt less than Ef cos delta. Vt less than Ef cos delta condition. So what happens if Vt less than Ef cos delta happens? Listen, my dear. So if Vt less than Ef cos delta means now the Q input of the motor will be what, my dear? Negative. The Q input will be now negative, am I correct? Because Vt minus Ef cos delta will be the Q value. So now the motor Q input will be negative. If Q input is negative means the motor will supply reactive power to what? The motor will supply reactive power to the supply. Supply or source? Supply or source? Source is the correct word. That is, the motor is in leading power factor condition and excitation will be over excited. Correct? Leading power factor condition means Q will be, that means this Ef cos delta is higher. Ef cos delta is higher means of course it will be in over excited condition. Okay? So we have to improve this leading to unity. We have to improve this over-excited condition to normally excited. That is the meaning of power factor control, my dear. That is the meaning of power factor control. So, what we have to do for improve this? What we have to do? We have to break this relationship, that is Vt less than Ef cos delta. So that what we have to do? We have to Ef decreases. We have to decrease Ef. That is, excitation should be decreased because it already in over excited condition. We have to decrease the excitation, my dear. What happens? If to improve this, we have to decrease for Ef. If Ef increases means, if Ef decreases, sin delta increases and cos delta also decreases. So combinedly Ef cos delta decreases. Combinedly what, my dear? Ef cos delta decreases. Ef cos delta decreases. So what happens if Ef cos delta decreases? What happens, my dear? We have Ef cos delta decreases means Q will be decreases, right? Initially Q was very high in reverse direction, in negative direction. Now Q starts decreasing. Q will be less. Q will be decreasing means phi will be tan inverse Q by P. If Q decreases means phi also decreases. Phi also decreases. If phi decreases means, my dear, cos phi increases. Cos phi increases. So cos phi increases from the leading to unity. The cos phi now finally what, my dear? We improved the power factor, but that's all, by reducing the excitation. So many questions are asked from this two topic, my dear. Power factor control of generator and power factor control of motor. If you start by hearting everything, you will have a 2 pages or 3 pages questions, one by one. But if you know the concept, like I wrote now in board by simply not looking anywhere, I simply writing before you, right? So likewise you can also think and write. That level you will attain. Clear? So any situation you may give, okay, give your situation. I will tell you what happens if excitation increases or excitation decreases. I will tell you anything you can conclude from these sessions. If you know these two equations, P equation, Q equation, and this excitation control, that's all. You will crack any question from this session. You will definitely crack any question from this session, my dears. Okay, so now the power factor increases, that's all. So it will increase from leading and over excited condition to, so Q will be decreases means now the machine is in under excited, not under excited condition, starts to, machine is in, or machine moves to normally excited condition from under excited condition. So that will be the result. Is it clear, my dears? Is it clear? So these are the 3 cases you have to always see what happen if you increase or decrease excitation. Suppose you are asking under this condition again is it increasing, means it will be again more leading. It will be more leading. Is it clear? That's all. Okay. So that's all, my dear. Everything you covered, right? So over excited condition or the motor acts like a capacitor. The motor acts like a capacitor. Leading power factor means motor acts like a capacitor. That's all. Okay? Is it clear? So as a conclusion, I will give you a table. As a conclusion, I will give you a table, my dear. That is, for first we will write for motor. Now itself it will motor. For motor, Vt equal to, first case Vt equal to Ef cos delta means UPF condition and the machine is said to be normally excited. Okay. Second one, Vt greater than Ef cos delta means it is in lagging power factor condition and under excited. And if Vt less than Ef cos delta means it is in leading power factor condition and we say that it will be over excited. So that is the case of a motor and generator. First one, if Ef cos delta greater than Vt mean or equal to Vt, first equal to Vt means UPF or normally excited. If Ef cos delta greater than Vt means lag under excited. If EF coastal less than VT means lead over excited. Bus. You have to conclude this for the easy reference. Okay? Not it, my dears. Not it. Okay? Is it clear to you? Is that everything clear to you, my dears? If you have any doubt, please mention in the comment section and start study very seriously, because assistant electrical inspectorate exam is going to come within three months, because up to April 13th you can confirm your confirmation, and after that within 1 month exam will be there. After that within one month exam will be there. So total you will get nearly 3 months. So prepare very seriously. Definitely in that 3 months I will complete my sessions. I will complete electrical engineering in that 3 months, sure. Okay? I will complete the syllabus. Okay, so now what is that? Now next topic is, yes, V-curve and inverted V-curve. Listen, my dears. Okay. Listen. Listen, my dears. So what is the meaning of V curve and inverted V curve means? First we can see V curve. So in V curve, my dears, in V curve, listen very carefully. If you plot the graph between the field current IF, where we are giving field current IF, my dear, in rotor, correct? In rotor is you can adjust IF, right? So field current IF against armature current IA, where you get armature current. In the stator you get armature current, in the rotor you apply field current. Okay, so that you have to note. Then if you plot a graph between these two parameters, you will get like a graph like this in the shape of a V. That's why it is called a V curve. And the peculiarity of a graph is there will be a particular field current IF, that be IF1. At that the armature current is minimum. The armature current minimum means that will be a condition of That will be a condition of Q is equal to 0. So this condition is Q is equal to 0 condition. Under Q is equal to 0 condition, what means? The reactive power flow is not there. So if the reactive power is not there, the stator of the machine only absorbs a small amount of current for transferring its active power completely to the load in the case of motor, or from the load to the or from the generator to load, or from the supply to motor in the case of a motor or generator, vice versa simply. So there the condition under Q is equal to 0 happens, so minimum armature current will be flowing. If you increasing the excitation, this is called over excitation region, and this is called under excitation region. Is it clear? So if you increasing the excitation from this unity power factor condition, what happen? The machine will lead to lead, that we already discussed now. The machine will lead to lead. Lead means, my dear, the meaning of lead power factor is what, my dear? Simply, suppose this is the voltage means, current will be leading, that's all the leading power factor. But we need not that, we need V and I should be in phase. That is the situation we require actually. This situation, and this is the voltage and this is the current I, this situation, these two situations are not advisable. One is lead and one is lag. Both are not advisable. Both are not good for the operation of the machine. Is it clear? So this we need the preferred condition. So after that, if you increasing the machine, it will be goes to over excited condition. The power factor will become poor. The power factor will become poor. And if you decrease the excitation from this condition, the motor will again goes to another poor condition, which is nothing but the lagging power factor condition. That also not desirable. That also not welcomeable. Is it clear? So that is the concept of V curve. And next, if you plot the same graph between the field current IF and the power factor, cos phi is nothing but one, my dear, power factor. Cos phi. What do you get? You will get an inverted form of V. We will get an inverted form of V called the inverted V curve. So there also you can see the same thing in different manner. What is that? A particular field current, there will be power factor maximum called the unity power factor condition, and both of the cases the power factor starts lowering. Either one is in leading direction, it will lower, and it is in lagging direction, it will be lower. So here, like an example, here will be 0.5 lag, 0.3 lag. Here will be what? 0.5 lead, 0.3 lead, 0.1 lead, 0.2 lead, 0.05 lead, like condition. Here 0.7 lag, 0.6 lag, 0.5 lag, 0.3 lag, 0.2 lag, 0.1 lag, like that condition will arise. So both the conditions are not desirable. You have to improve that once. So that's the meaning of V curve and inverted V curve. Is it clear, my dears? Is it clear? Everything is clear to you? Next, voltage regulation of alternator. Voltage regulation of alternator. Voltage regulation of alternator. So what is the meaning of voltage regulation? Before that, we have to note the equivalent circuit of an alternator media. So this will be VT, that is the induced EMF in the stator or the armature. So this is Ri, this is XS. This XS will be equal to XL plus XA. Okay, and there will be a current flow which is nothing but the armature current IA. So voltage regulation, percentage voltage regulation will be equal to EF minus VT divided by ET into 100. That is the changing terminal voltage from no load to loaded divided by loaded condition, that is EF minus VT divided by VT. Is it clear? So that is the volt percentage regulation. So normally the regulation value will be lesser for good system. If you have two system in which one regulation value is 5% and another regulation value of 3%, which system is good means this is good system. That means if the regulation value less means there is less difference between no load to full load voltage happens, that is a very good system. That is a very good system. Okay, so there are three methods in order to measure this regulation in alternator we are using. The three methods we are using for finding the regulation. First one is impedance method or EMF method. Impedance method or EMF method. This is very oldest method, my dear. Oldest method. This method is also called pessimistic method, because the value obtained from this method will be higher than the actual value. That means normally suppose the machine having a regulation of 5%, suppose you measure the regulation using impedance method or EMF method, you will get 8 or 10%, that is none. But higher than the actual value, if the regulation is higher means it's a bad system. So this method is a bad method. This is the bad method. That is why it is called a pessimistic method. Pessimistic means no hope in that method. That is the meaning of pessimistic method. Second method is called the MMF method. This is actually a graphical method. That is a calculation method, my dear. Calculation method. This is a graphical method. And this method is called optimistic method. In question paper, this word is only used for long period. That is, the optimistic method is which method? And if the result is optimistic means super good system is that. If the system is super means the value obtained from this method will be higher or lesser, my dear? Lesser than the actual value. Lesser than the actual value. Okay, that is why it is called the optimistic method. And third method is called the ZPF method. This is the widely used method and most accurate method. It is a widely used method and most accurate method. That means neither too much optimistic, neither too much pessimistic. You will get a normal ray. I mean, if the voltage regulation of the regulation of an alternator actually it is 5% means by using ZPF method you will nearly get a regulation like 4.9% or 4.5%. Near to the original value of regulation you will get from the ZPF method. ZPF method is called zero power factor method, my dear. It is also a graphical method. Only these things you have to note. No need to what is the procedure for that, what are the procedure, no need to find that all. You just need to remember this. You just need to remember this. Is it clear, my dears? Is it clear? Next, OCC of an alternator. OCC means what, my dear? Open circuit characteristics. Okay. Yes. Only we are giving P input now. And the stator is dark connected, right? And this is open circuit. So, open circuit characteristics means, my dear, suppose this is the rotor and this is the stator. Sorry, yes, this is the rotor and this is the stator. In the generator, we are giving mechanical power to the rotor. That is only the active power. So, P input is the only active power that you are giving. And this is nothing but field excitation, and this is the stator from which we are taking the output voltage, correct? And that is normally star connected. We know that the alternator, stator, or the armature will be what? Star connected. So this is the situation. So here the armature current will be 0 because it is open circuit, right? So you have to plot a graph between the field current and open circuit voltage. So this will be the nature of the graph. This will be the nature of the graph. This is called saturated region. That means if you plot the graph between the field current against the open circuit voltage, that is simply you can measure open circuit voltage by inserting a voltmeter here, and you have to increase the field excitation, you have to increase EF so that IF will be increased. So if you increase the IF, initially the voltage will be increasing, you again increase the IF, it start flattening, and after that, my dear, it is actually this. It is actually this, and after that a particular voltage is attained here, which is VOC. That's corresponding field current is called IF1. If again you increasing this field current, means the core of the machine got saturated and it will not have the capacity to generate more EMF than that. So that's voltage will be again constant. Even if you increasing the field current to infinity, the voltage will be almost constant. So now this test is used to find rated voltage. What is that? Rated voltage. So this is the OCC. This is the OCC. And next is SCC of alternator. Short circuit test or short circuit characteristics of alternator. Similar manner, my dears. This is rotor. This is EF and IF. This is the mechanical active power input. And this is the stator. Now the stator got short circuited, so that IA will be there and V0 will be equal to 0, or V will be simply equal to, or VT will be simply equal to 0, my dear. Terminal voltage will be equal to 0. Terminal voltage will be equal to 0. So what happens in the characteristics? So again, field current against short circuit current. field current again short circuit current graph, you will get a graph like this. There will be IF2 and this is called the rated current or I rated. So the nature of the graph will be like this, is a straight line. So under this particular field current IF2, there will be a rated current which is flowing in the armature side. So after that, if you increasing, definitely the armature winding will be burned. The armature winding will be burned and the machine gets damaged. So the nature of the field current is such that IF2 will be the current, maximum value of field current at which we get a rated current as the output. So now this is the current, this is the voltage, correct? This is the rated open circuit voltage. This is the current graph. Okay, so these are the open circuit and short circuit test on the alternator. Okay. Next, very important term, my dear, short circuit ratio. SCR. Short circuit ratio means, short circuit ratio means field current required to produce rated voltage on open circuit to the field current required to produce rated current in short circuit. So the ratio between these two will give you the value of short circuit ratio. Or I can say like in the previous figure, IF1 was the field current required to produce the rated voltage, and IF2 was the field current required to produce the rated current. So this is the SCR. Or we have another equation for SCR. XCR will be inversely proportional to 1 by ZS. SCR will be inversely proportional to 1 by ZS. Or SCR, if ZS equal to RA plus J into XS, RA plus J into XS, RA is negligible. So ZS will be nearly equal to XS, correct, or J into XS. So SCR will be inversely proportional to 1 by XS. This is very important. This is very important. This is very important. That means if, and also for a good machine, SCR should be very high or low excess. If the machine is very good, it having very high SCR. If it have a very high SCR means its synchronous reactance excess, that will be very low. That means if it is said to be a very good machine, then its excess will be very less. Excess not that much high. It is comparable with RA, then it is a perfect machine. Then it will be a perfect machine. So low excess. Okay. So suppose you have, suppose you have two graphs, my dear. open circuit voltage and short circuit current. You combinedly plot two graph in single graph. You can combinedly plot two curves. One is for short circuit, this is for SSC, this is for OCC, and you got something like this. And in another machine, my dear, I have to compare this SCR now. If the question paper is very tough and if an examiner really want to know your knowledge level, this type of question they may ask. This type of question is, which machine is good machine? The question is, which machine is good? Which machine is good? Focus on it. See, my dear, let be machine number 1, let be machine number 2. So what will be SCR1? SCR1 will be equal to the field current required to produce the rated voltage, open circuit voltage, IF1 divided by IF2. Am I correct? IF1 divided by IF2. And what is SCR2? Which is equal to again IF2 divided by IF1. Which SCR is higher? IF1 here it is lower and IF2 is higher, so definitely this will be smaller. Here IF2 will be higher and IF1 will be lesser, so definitely this will be higher. So SCR2 is greater than SCR1, so machine 2 is good. Bas. Machine 2 is good. Did you see anywhere like a question? Did you see anywhere? It's a super question. It's a super question. The answer is simple, but if you know the concept only. If you really know the concept, then the answer will be super. Note it. Is it clear? Next, advantage of high SCR. If the SCR is high, what? Excess will be lower. If excess will be lower means leakage reactance will be lower. Correct na? Excess is the leakage reactance na? So excess is higher means leakage reactance will be lower. Leakage reactance lower means voltage regulation will be better. If voltage regulation is better means efficiency will be higher. Efficiency will be higher. That's all. And armature reaction will be what? Decreases. If excess less means, excess start decreasing means what happens? Definitely the armature currents goes down, right? IA goes down. Armature reaction will be less. Okay, is it clear, my dears? Is it clear? So that are the advantage of higher ICR. So that's all for today. So let's meet again with a new topic on tomorrow. Bye.